Good morning. My name is Christina Fennell, and I'm going to explain the molar solution question for the bioinformatics midterm. So first, I'm going to show you what the question is. So it says for me to write one or more multiple functions to calculate the amount of chemicals needed in grams to make a molar solution for copper sulfate, I believe, magnesium sulfate, and calcium nitrate. I believe. I'm trying to rusty in my chemistry. And your function should specify volume in milliliter and molar concentration in millimolar. So this is similar to a question we did in class, and it gives us a few demonstrations, like use 0.5 liters and 0.1 mole of copper sulfate, and then use 0.25 liter and 0.5 mole of magnesium sulfate for your example code. So here's the right answer, and here's what I'm going to explain how I got it. So just for the name of the function, just do molar solution. Oops, underscore solution. And I'll use a function tool to use to put an order of concentration, volume, and formula that will be needed to calculate everything. Okay, my brackets. And then here for my formulas, okay, so for my first I'm going to use the formula weight, or the mass of 1 mole, the molar mass, chemistry, of each of those compounds I just stated. So formula weight is just a variable name for it. So my characters, it's going to be kind of a vector right now. So it gives us that the molar mass for copper sulfate is 159.61 grams per mole, that magnesium sulfate weighs 120.366 grams per mole, and that calcium sulfate weighs 164.088 grams per mole. And then we're going to name these to keep everything in order. And so I'm going to name the formula weight, or the molar mass that were given to us. So again, it's going to be copper sulfate, excuse me, magnesium sulfate, and calcium nitrate. Yeah, I think that's it. And then we're going to use the formula weight. Do this here. This is similar to another question. It's probably why I did it. Bracket a formula, a subsetting essentially. To the formula, just to select the formula in general. So subsetting that. And then for my formula to calculate the concentration, the amount of chemicals needed in grams to make a molar solution, you have to utilize that that equation. In this case, it's the formula weight and the molar mass of that times the given concentration of the chemical times the volume, the volume of that chemical divided by 10 to the 6, because we want to make sure that all the units are in milliliter and millimolar as instructed. So that will be, so we're basically subsetting it to make, I'm sorry, it's so hard to say. But basically, we've now created the equation used to calculate the amount of chemicals needed for a molar solution that was provided for us. So That should be it. Before we can run this, I have to make sure this session is, the directory is correct. So we're going to choose directory, go to, for me, it's in downloads. I'm going to download exam 1, and I'm going to go to Molar solution. This is where everything is. You can see that here. And I'm going to run this function to make sure it works properly. Well, it's going to be listed in my global environment mostly. So where is it? Here it is right here, Molar solution. Well, here it is, function. My function is here, great. And then I'm going to make sure that it works in my given example. So for Molar solution, here it is. And then I have to be careful here because I ask for things in millimolar and milliliter. Because the function is listed in concentration volume formula, I have to make sure it's in the proper order too. So 0.1 mole is equal to 100 millimole, and then 0.5 liter equals 500 milliliters. And then I gotta make sure that it's labeled properly so there's no confusion about what I'm talking about, which compound I'm talking about. And similarly, Molar solution, and it has to be 200, oh sorry, that says 0.5 mole, so it'll be 500 millimole. And then as a 0.25 liter, it says 250 liter. And again, make sure it's labeled properly. So now that that's there, I can make sure that it's listed properly. I'm going to run it. Oopsies. There must be an error somewhere. Oh, sorry. Typo. A little syntax error. Here we go. Make sure this is run properly again. And then do this again. And it's hard to see. Hold on. At the bottom here, you can see that it says 7.9805 pi mil. Let me see what it is. In grams, so 7.9805 grams to make the molar solution that's provided of that compound. And then here, we're going to do the same thing for magnesium sulfate and get 15.04575 grams of this compound needed to make the proper molar solution. And again, this is similar to another molar solution problem, so it makes it using that to help me in this problem. So that's how I came to this answer. Thank you.